So good morning. In the last class we have seen 5 types of functions: one-to-one function, many-to-one function, on-to function, into function, and also bijection. Now in the next aim, aim number 4, we are going to see about the next type of function called as inverse function. So before going to the inverse function, we will see about the inverse of function. Later on we go with the inverse function. So inverse of a function. The inverse of a function is obtained by interchanging the domain and range. That is, say for example, let us suppose that f be a function given by f is equals to order 1 comma 2, say 3 comma 4, 5 comma 6, 7 comma 8. The inverse of the function is indicated or denoted by f inverse of function, and is obtained by interchanging the first and second coordinates of these ordered pairs. That is 2 comma 1, 4 comma 3, 6 comma 5 and 8 comma 7. So by interchanging the x and y coordinates of the function f, we get the inverse of the function f. The inverse of the function is different from inverse function. Here the inverse of a function, if f is a function from a to b, is a function, the inverse of the function is indicated by or denoted by f inverse, is a inverse of function would be from b to a, but it is not compulsory that the inverse of function should be a function. So the inverse of function is different from inverse function. Now let us go ahead with the inverse function. It's going to be 6th type of function is going to be called as inverse function. So if f is a function, let us suppose that f is a function given to you like 1 comma 3, 2 comma 3, 4 comma 5, 6 comma 7. Let us take the inverse of the function. The inverse of the function f is given by 3 comma 1, 3 comma 2, 5 comma 4 and 7 comma 6. This is the inverse of the function, but this is not a function. It is just the inverse of the given function, but it is not the function. Why it is not a function? Because the first coordinates are repeated, so therefore it is not a function. In case if I take a function g such a way that we have got the ordered pairs into it as 1 comma 3, 2 comma 4, 5 comma 6 and 7 comma 8. Now if I go with the inverse of the function g, I get it as 3 comma 1, 4 comma 2, 6 comma 5 and 8 comma 7. Observing these two functions carefully, in this the inverse of the function f is not a function because the first coordinates are repeated, so it is not a function. Whereas in the example second, that is g is a function, we have taken the inverse of the function g and observed that all the first coordinates are going to be different. So as the first coordinates of the inverse of the function g is different, so it is again becomes a function, so it is a function. So what we have done is we have considered two functions, we have taken their inverses and we have checked whether they are functions or not. If the inverse of the function is a function, such kind of function we call it as inverse function. Whereas the inverse of the function f is not a function, so this is not an inverse function. So the inverses of the functions need not be functions. If the inverse of a function becomes a function, then such kind of function we call it as an inverse function. So here the inverse of g is called as an inverse function, whereas inverse of f is not an inverse function. The inverse function is indicated by g inverse. So g inverse is nothing about 3 comma 1, 4 comma 2, 6 comma 5, 8 comma 7. It is called as the inverse function. Whereas here the inverse of f, even though it is indicated by f inverse, it is not a inverse function. So we have to be very careful in the notations. Here the inverse of function is indicated by f inverse, inverse function is also indicated by f inverse. So do you have any condition to say whether the function is going to be inverse of functional or inverse functional? So there is a condition for it. The condition is if the function is a bijection, then the inverse of a function becomes a function. So in that case we can say the function as an inverse function. So I am keeping these notations aside and let us go with the definition of the inverse function. If f maps a to b is a bijection, that is if it is a both 1 to n and on to, then the inverse of the function f, that is indicated by f inverse b to a, is said to be the inverse function, is said to be the inverse function of f. It is denoted by f inverse. Here we say it as inverse function only when f is a bijection. If f is a bijection, the inverse of the function becomes a function. So if f is not a bijection, the inverse of a function will not become a function. So in that case we'll not say it as an inverse function. So the example which I have told you in the previous case, I have told you that f is going to be inverse of function, whereas g is going to be called as an inverse, g inverse is called as an inverse function. So here in the case if f is a function, let's go to some example. Say f is a function from set A to set B. Let us take some numbers, say 1, 2, 3 and 4, 5, 6. So if you observe carefully here, the images of the elements of set A are already given here. Now if f is a function from set A to set B, the inverse of it also, if it is a function, the function is called as an inverse function. First, to take the inverse of function, what we do is we need to interchange the domain and codomain. So I take the codomain, and the codomain of f becomes the domain of f inverse, and the range of f, or the codomain of f, becomes the domain of f inverse, and the domain of f becomes the range of f inverse. So here the elements of B are going to be 4, 5, 6 and the elements are going to be 1, 2, 3. As because 1 is having the image of 5, so here 5 becomes the pre-image of 1. The same way as 4 is the image of 2, here 4 becomes a pre-image of 2, and here 6 is the image of 3 under the f function. So 6 has got the image 3, or 3 becomes the image of 6 under f inverse. Observe it carefully here. Even though after interchanging the domain and codomain, still it remains as a function. So because it's a function, now f is called as, f inverse is called the inverse function. So the inverse of this function became the inverse function because f is a bijection. So finally we can understand that since f is a bijection, f inverse became an inverse function. Imagine that in case f is not a bijection, let us take an example where f is not a bijection. That means I will map 3 to say 5. Observe carefully, in this case the function is not a one-to-one function, it is not a onto function. In this case, if I take the inverse of the function, I get the codomain as a domain of f inverse and range domain as a range of f inverse. So here, if I observe carefully, the image of 3 here is 5, so 5 the image must be 3 here. But as per the definition of function, what is the function? Function is nothing but a function, a relation from A to B is said to be a function if every element of the first set is going to be associated with a unique element of set B. But that is not happening here because f is not a bijection. The inverse function does not exist. So it is not a function, so that's the reason we call it is not an inverse function. So why it is happening that it is not becoming a function? The reason because f is not a bijection. If f is a bijection, then obviously the inverse of the function also becomes a function, so then it will become an inverse function. So in this case, in this example, we call it only as the inverse of a function f, but will not call it as an inverse function. So we have to be very clear about when you should say it as inverse function and when we should say it as an inverse of function. So a function is inverse of a function is said to be inverse function only when the function is going to be a bijection. If the given function is not a bijection, the inverse of function is remained as inverse of function, but it is not called as an inverse function. So here is the best example for inverse function. So the important note in this is what we observe here is we observe that domain, if in case if it is an inverse function, say imagine this, that A contains the elements. To make it as a bijection, we need to have equal number of elements. Say I have got 1, 3, 5 and A, B, C. Now 1's image is B, 3's image is C and 5's image is A. And if I go for the inverse of the function, the inverse of the function becomes such a way that because the inverse of the function is going to, if it's a bijection, that's the reason inverse of function is going to become a function, therefore it's going to be called as inverse function. In this case, the range of f becomes the domain of f inverse and the domain of f becomes a range of f inverse. So here the images are going to be, A's image is going to be 5 and B's image is going to be 1 and C's image is going to be equal to 3. So observe carefully, as f was the inverse, f was the bijection, the inverse of function again became a function, therefore this is now called as an inverse function. So the important point what we understand here is, we understand that important note what we have to write down is the domain of f became equal to the domain of f became equal to the range of f inverse, or you can also call it as codomain of f inverse. And same way, the range of f is ABC, the range of f became equals to domain of f inverse. So these are the two important points we need to remember. So finally, what can you confirm here is a function, if it is a bijection, the inverse of the function also becomes a function, so it is called as a, hence that is called as an inverse function. So if f is not a bijection, the inverse of the function remains as an inverse of function, but it is not called as an inverse function. Now let us work upon some problems based upon the inverse function concept. Let's go to some example, the kind of questions what they ask you upon the inverse function. So the question is, find the inverse function of a function f maps R to R defined by f of x is equal to 3x minus 5. If it exists. So here the question says that you check whether the function is going to be inverse function, that the inverse function does it exist or not. If it exists, he is asking us to find the function. So finding the function means finding the rule for the inverse function, as every function has got its own rule for the function. The same way, if the inverse function exists, we are supposed to find the rule for the f inverse. So that's what the task is. So let us go ahead. First of all, we are supposed to check whether the inverse function exists or not. So as per the definition of inverse function, the inverse function exists only when f is a bijection. So here first we are supposed to check whether this given function is going to be a bijection or not. To check the function is a bijection or not, we need to say whether the function is going to be a one-to-one function or not. So first of all, write down what is given. Given f is a function from R to R defined by f of x is equal to 3x minus 5. Now let me check whether the function is going to be a one-to-one function or not. Observe the process what we are going to do. So to prove, first we are going to prove f is one-to-one. So before we prove it is one-to-one, we need to confirm whether the function is going to be one-to-one. As I already have told you a short tip saying that whenever the function rule is a linear function, obviously the function becomes a one-to-one function, because different elements you substitute from domain, it is going to give you different images. That is, what are the elements you take, from the domain. The domain is real number set, codomain is also real number set, and f is given by the rule 3x minus 5. So because it contains real numbers, let me just check for negative number and positive number with the same numerical value with opposite signs. If I check the image of minus 1, the image of minus 1 is going to be 3 into minus 1 minus 5 gives you minus 8, and the image of 1 is going to be 3 into 1 minus 5 is going to give you minus 2. That means, say numbers having the same numerical value with say different signs are having the different images. This is a way how you need to always check. Take some two numerical numbers. If that domain contains two numerical numbers with the opposite sign, take those numbers and check their images. If the images are different, obviously you can understand that the function is going to be a one-to-one function. As it is observed that the function is a one-to-one function, let us go with the property. So for all, let us suppose that x1 comma x2 be two elements from the domain R. If such that we'll take their images equal, that is, if f of x1 is equal to f of x2. If the images are equal, as per the property, the elements must be equal. If the elements are also equal, we can understand that the function is going to be one-to-one. So as already we have observed that the function is going to be one-to-one, you can just confirm it once again by using this property. So if I say f of x1, if I take f of x1 is going to be 3x1 minus 5 and f of x2 is going to be 3x2 minus 5, that is the image of x1 under function f is this, the image of x2 under function f is this one. So here minus 5 gets cancelled on both sides, we get 3x1 equal to 3x2. Now 3 gets cancelled, we get x1 is equal to x2. Therefore, what you can understand is, if the images of two elements are equal, the elements are also same. That means we can confirm that f is a one-to-one function. Of course, by observation we already confirmed as a one-to-one function, but once again by using the property we also have confirmed that the function is a one-to-one function. So once we have confirmed that f is a one-to-one function, next thing we need to check is whether f is going to be onto or not. So let us try to check f is onto or not. So to check or to find or to prove f is onto. To prove f is onto, the important thing what we need to know is we need to get the pre-image rule. How to get the pre-image rule? Here he has already given that the domain is real number set and codomain is also real number set. f is a function from R to R. So here I am going to check whether the function is going to be an onto function. As per the definition of onto function, every element in the codomain need to have at least one pre-image. So in this case, what you are supposed to do is we need to take any element randomly from the codomain and check whether the pre-image for that exists or not. If any one particular element does not have a pre-image, then obviously the function is not one-to-one. So here let's check the pre-image rule. To check the pre-image rule, what we do is we take some element y from the codomain. Let us suppose that y belongs to some codomain R, such that we equate that to the image rule. The image rule is given as, if x is the element given to you, the image rule is given as 3x minus 5. So we equate y to 3x minus 5 and we solve for x, we'll get the equivalent value of x. So we get y plus 5 equal to 3x. So x is equal to y plus 5 by 3. So I got the x value as y plus 5 by 3. Anyhow, by using the image rule, I got the pre-image rule. So it is not required to write the image rule in the diagram. So I'll remove it. Now, with the help of the image rule, I got the pre-image rule. So what we are going to do with it? What we are going to do is, we are going to find whether every element in the codomain do have a pre-image or not. So let me just try with some numbers. Let me just check with 1. If I find out 1, for the pre-image of 1 must be 1 plus 5 by 3, that is going to be 6 by 3 is going to be 2, and 2 is present in the domain. So in this way, keep on trying some numbers. If you could find all the pre-images for every number what you take, then obviously the function is going to become onto. Here, whatever the number you substitute, whatever the real number you substitute, the pre-image of it is going to be added with that 5 and divided by 3, again gives us a real number itself. So whatever the number you take from the codomain, for every number we are going to have a pre-image. So by this you can confirm that f is going to be a onto function. So for all y belongs to R codomain, there exists at least one x belongs to R domain from the domain such that f of x is equal to y, such that f of x equals to y. So therefore f is a onto function. So f is a onto function. So far what we have seen is, we have seen that f is a one-to-one function, and also we have seen whether it's going to be onto or not. So what we confirmed is, in this particular problem, f became one-to-one, f became a onto function. Because f is a one-to-one and onto, we can say that f is a bijection. So because f is a bijection, the inverse function exists. So here finally I can say